Today we're going to look at some of these power inverter options which I had. This is right here is an 80 watt inverter from Harbor Freight Tools. I actually bought this 7 years ago and I've used it a few times, but I haven't really had the power source to do it until now, where I have all the system which I have recently set up. Same thing for this one. I also bought this one around the same time. This one is a Black & Decker one. It's 200 watts. Not only do you have an inverter and a USB port, but you also have a pass-through for your 12 volts. So there you have your 80 watt and your 200 watt. This one actually has screw terminals instead of a cigarette lighter. I don't think that they make these cigarette lighter ones past 200 watts just because of the limitations of the socket itself. But now for the more conventional one, which this one is a bit more unconventional. It's a battery backup surge protector uninterruptible power supply thing. The thing with these is that they have a battery in them, and whenever the power shuts off, it has its own power inverter, which it uses the built-in 12 volt lead acid battery to power these sockets, these three right here, and these three are just surge protector pass-through ports which do not get battery backup. So what you would do is you would plug in your computer in here, your monitor in here, and maybe your router or phone, and you could have your computer be powered for 5 or 10 minutes depending on what your battery life is. Or if you wanted to get a longer runtime, you would use less power. So maybe you would have like a lamp or low power computer just to run some devices in a power outage and have them on for maybe up to an hour. They do build these UPSs to run computers for hours and hours, but this is not one of them. This is one of the lower end ones. It says 500, but this is not the wattage. They just use this because it's a bigger number and it's more marketable, I guess. But really this is a 300 watt inverter, so it's actually more powerful than the both of these combined with their wattage. Actually, speaking of that, I think you can actually combine the wattage of more than one inverter, but they do have to be the same one and you have to wire them in a certain way. But here, just use this one. So this is probably going to be the one that I use in the system for an inverter. Also, again, you get more outlets to use, so I could plug in a few things. But I have taken the battery out of this thing. It says remove screw to access battery. It's always out because there is no battery. There's just a bunch of wires. This is what I've replaced the battery with. This is a pretty thick wire, and it just goes out to these end terminals, and you can see that I have it connected up using the terminals. So basically how it was that the battery has terminals on it, and I put terminals on this wire and connected them together. It's still not very, it's not very good. It just came off. I wired this up a few years ago, well, like 1 year ago, I guess, but 1.5 years ago. So I didn't really know about the best way to connect the wires back then. And well, what I'm gonna do today is I'm gonna try to clean this up a bit more and get it ready to actually use it. So that would mean soldering the wires, connecting everything better, so it won't just come loose like this one just did. Well, let's try to pull the other one out. Yeah. So this one is a bit more resilient. You can see the terminal that's actually supposed to go on the battery, but it did pull out. And yeah, these kind of clips that you have your little crimp-on terminals, I've never had very much luck with them. Usually they come off. Yeah, they just slip right off. So I'm gonna solder this hardwired, and then how this cable was is I had a hole in the back of the UPS where the wire would feed out, go up through there. I don't really know why I did that when I could just have it go where the power wire goes out. I took out the power wire because we're just using it as an inverter. So that required basically I take out the power wire, take out all the surge protector outlets, as well as the buzzer, which warns if you're on battery backup. It would beep continuously, so that's off because its normal state now would just be for the inverter to be running. So you can see that has a big transformer right there. I think it uses this to charge the battery as well as for the inverter, but once again, that stuff's removed. So let's get all the duct tape out of this thing and take it apart and try to make this thing fit for use. So here's the interior of this device. You have this big transformer. This is actually most of the weight of this power supply when there is no battery. Of course the battery is also pretty heavy too. But so there's that, and our circuit board right here. It also has some of these wires which they would go to the surge protecting outlets, but those are not here anymore. Now we have our battery backup outlets, the power wires, and the transformer. So let's try to create some sort of way to wire these out. As we said, we want them to go out of the power port, which is here. So they're gonna go something like that, and they're gonna drape out there. So let's cut out these wires and strip them back. I was considering soldering these wires, but I did find some wire nuts which are big enough for these wires to fit. If I were to solder them, that would have taken a very long time and I would have had to strip back a lot of wire. So this is a better solution and it is stronger as compared to this wire. It goes all the way to this end and you can see it has more of these terminals. I don't really have the proper thing to crimp these down, or maybe I don't do it right, I don't know, but it just comes off really easily, even though I did crimp these down at least a little bit. So what I'm gonna do with these ends, I don't know, maybe put alligator clips on them, or if I can get those Anderson power pole connectors about this size again, I could use those. But for right now we just have this, and it goes through the wire. I can put it through where the power cable used to come through, so we can just get it normally, go through the battery, the power, and I did have to cut out a lot of this area where the battery box used to be, so I could snake the wires back on through. But as you can see, this is kind of rough, so I'm gonna get a file and file it down. I don't think that this plastic would cut the wires, but just to smooth out the edges I can dial it down. Here is the finished setup of this power inverter UPS conversion. Basically what I did is I just ran the wire out and it's going to this battery. Interestingly, this UPS originally took a 7 amp hour battery. This one right here is a 12 amp hour battery, and there's no reason why I can't just plug this into some bigger batteries or some more batteries if I get that kind of system going. But for right now, I have this, and this is a lamp that's plugged into it right now. So it's this one right here. So what I'm gonna do is, I don't really have really good clips for this. Basically what I'm doing is I'm getting alligator clips, and they're not wired to these wires, they're pretty thin, but I'm just kind of going like that and using the clamps to clamp them in between the two wires. So let's maneuver this wire out to this edge over here and plug it in. So we should have a good contact now. So let's plug it in and let's turn the power on. It's powering up. See light screen, and we are officially inverting power. Light is on. Just to prove that it's that light, you can see how we both. So unplug this, and lights off. Plug it back in. Lights on. Let's try all 3 of these sockets. This one, and this one. So yeah, we do get power inverted coming out of there. I don't think that this thing actually has a fan on it, which the UPS, it doesn't really have fans, but maybe I'll add a computer fan just to put it in there if I want to run this for a longer period of time. A lot of people do this conversion, but one thing that I sometimes forget is that the UPS might not be designed to run for long periods of time, which I mean, for like an hour it's fine. I mean, also I took the battery out of there, so there should be better cooling, I think, but it might be a good decision to add, for example, a computer case fan, which is probably what I'm gonna do. If I could put it up here, I can exhaust. Again, these ports for these outlets are not being used, so go around there, and that can just provide additional ventilation, and it can go through the existing wire configuration. It's a 12 volt fan, so 12 volts, same as what's going through here, and we could get that going. I actually think I might do that pretty soon, but for right now, let's turn off the power. So you do have this soft on-off switch rather than just unplugging it, which this is going to be hardwired to whatever electrical system that I'm making. And let's put the battery back with the solar panels. Actually, this battery was charged from solar, so that light was being powered by solar indirectly. The battery charged over the past few days, and it can indeed run a light. I use these kind of lights to run all the lights in my room. I don't use light on the ceiling fan up there. You can see those lights, they are incandescent lights. I don't use those just because they're kind of inefficient and I can't angle them directly, but I do use the fan. We use solar powered fans. No reason why I can't get a bunch of these, more of them, and wire them up separately. So in the next video about this, I will have a fan and probably make a shroud for the fan as well. And get this thing with better ventilation as well as leads on the end of the wire, so we can have this in some kind of place to where it can be installed and just used every day.